which line I'm on. Pretty easy activity. We're going to plot each line and then see which points are on which line. So line number 1 has a y-intercept of -6 and a slope of 1/2. So up 1/2. And we should have gotten a graph that looked like this. Excuse the sniffles. So here is line number 1. This is line 1. Now I want to draw line 2. Now line 2 has a y-intercept of 9, and its slope is -2, meaning -2/1. So +9 down 2/1. So double check that your graphs are correct. And then we're going to be checking some points to see which graph they live on. So here's line 2. Line 2. So the first point, 2, 5. 2, 5. That's the point 2, 5. It is only on line 2. -2, -7. -2, -7. That is only on line 1. I'm going to use a darker green. Line 1. 1, 4. Let's see. 1. Oh, that's not on either line. That's neither. 8, -2. 8, -2. That's line 1. 6, -3. So 6, -3. That's on both of the lines. So that is on both. -5, 5. Oh, that's neither. Now, how about these last two? How did you do on those? Which line did they live on? Well, we'll try both of them, both lines, and see which one they fit in. So I'm using this first point, and I'm going to use line 1, which was y equals half of x minus 6. We're going to see if this point actually works. So 17 equals 1/2 times -4 minus 6. So half of -4 is -2. -2 minus 6, does that equal 17? No. What about line 2? Well, line 2 was y equals -2x plus 9. So we're plugging in -4, 17, so 17 goes in for y. So remember, this is a way to test to see if a point is a solution to an equation. -2 times -4 is +8 plus 9. Yes, that one works. So that one lives on line 2. What about 16/2? Well, I need to start with line 1. Its rule, whoops, that's supposed to be a 1. Y equals 1/2 x minus 6. So I'm plugging in 16/2. So 2 equals half of 16 minus 6. Is that true? Half of 16 is 8 minus 6. Yes. Will it work with the other one? So 2 equals -2 times 16 plus 9. I'm starting to think a no here. That's a no. So that one only lives on line 1. Now, when we were talking about a system of equations yesterday, it had to be that that x value gave me the same y value for both equations. Or that it was where both lines crossed. It is a solution to both equations. So let's go to our note-taking guide. So our main concept today is to be solving systems with equations. So the main concept for our notes today is that we're going to be solving systems with equations in slope-intercept form. Slope-intercept form is your y equals mx plus b. Y equals mx plus b. Now, to truly be a solution to the system, it has to work for both. It has to make both equations true. In other words, it's going to be where those two graphs are crossing. It lives on both lines at the same time. So, what if we were just given a point and asked to see if it's a solution to the system? So we're going to check each of the lines. So just like we did in the warm-up, I'm going to plug in the x and the y. So negative 6 equals 3 times 4 minus 18. 3 times 4 is 12. And 12 minus 18 is negative 6. So it did work in the first one, but we have to check both. So let's check line 2. The y value equals negative 2 times the x plus 7. Negative 6 equals negative 8 plus 7. Does negative 6 equal negative 1? No. So while it's a solution for the first line, it's not a solution for both. So it is not a solution to the system. So notice when they give you two lines, we have to check both of them. So we're going to use the same point. We're going to check line 1. So negative 3 equals 15 minus 18. 15 minus 18 is negative 3, so it worked in the first one. Does not guarantee that it'll work in the second one. Negative 3 equals negative 10 plus 7. Hey, this one's looking good. Negative 3 equals negative 3. So this would be considered a solution to the system. So the two ways we can solve a system of equations is that we can graph them, or we can use the algebraic method we introduced yesterday. So graphing, we're going to graph each line. So y-intercepts at 1. This one has a slope of 2/3, so up 2 over 3. This is kind of hard to see. Up 2 over 3. It's extra hard to see when you're not feeling too well, so I apologize. Down 2, back 3. Down 2, back 3. And I'm going to see, I do have a ruler back here. That's awesome. So I'm going to make my line. So that's line 1. Line 2 had a y-intercept at 9 and a slope of 2 over 1. So up 2 over 1, I just ran out of real estate. But I could go backwards with a down 2, back 1. Down 2, back 1. Oh gosh. Back 1. It's kind of hard to do on this. Down 2, back 1. I think it's going to be about there. Now the problem with the graphing technique. What if I didn't plot my points very well like I just did there? Because I was having trouble seeing the grid. What's going to happen? I'm going to be kind of guesstimating where I think the solution is. And I think it looks like it's at about -6, -3. The problem with graphing sometimes is that it's hard to tell where they're crossing. Because we've gotten solutions of x values that are decimals. What if that happened here? It'd be really hard to tell. But let's see if that one works. How can I test to see if it's a solution? Well, I'm going to plug it back into each equation. So I'm going to go to line 1. Y equals 2/3 x plus 1. -3 equals 2/3 of -6 plus 1. 2/3 of -6. Well, 3 goes into -6 -2 times. -2 times 2 is -4 plus 1. It works. Yay! But just because it worked in that one doesn't guarantee that it's going to work in the other one. -3 equals 2 times -6 plus 9. 2 times -6 is -12 plus 9. It worked. So while I was kind of guesstimating on my graph, it did work. Now the foolproof way to do this is to also do it algebraically. So the algebraic method, we're trying to find what x values make the y's, both of them the same y value for the same x. So it's a solution in both. Like we're trying to make them meet. So one way to do that is to take this equation, 2/3 x plus 1, and we're going to set that equal to 2x plus 9. Now I mentioned on the last video how to get rid of the fractions really easily. The way to get rid of the fractions is to multiply both sides by a common denominator, which here the only denominator is 3. So this is a keen little trick. I think it's keen. So I'm going to distribute 3 on each of these equations. So 3 times 2/3 is just going to give me a 2x. 3 times 1 is 3. When I distribute on the other side, 3 times 2x is 6x, and 3 times 9 is 27. Now it's a lot easier to work with. Depending on how you like to solve your equation, I'm going to get all my x's on the left side. And I get -4x plus 3 equals 27. -4x plus 3 equals 27. My camera keeps stalling out. It knows I don't feel good. -4x equals 24. Divide by -4, and you get x is -6. Now remember, our solution is a point. It's an x, y. It's both. So I need to find the y that goes with that. I can go back to either equation. I like the second one. And I'm going to substitute that in for x. So y equals 2 times -6 plus 9. -12 plus 9. Looks familiar because we just did it on the other page. And we end up with -6, -3, which we should have, because that's what we got on the graph, and we've already checked it. So being able to check to see if a point is a solution or not is very, very important. So the next thing you'll be getting is a think pair share. I want you to explain how you can check if a point is a solution to a system of equations. Put it in your own words. Write it in sentences. Then, working with your partner, I want you to try these two. And we're going to check these here in a second. Now, I'm going to want you to turn in your prompt when you turn in the practice problems you're going to get in just a second. But I'm going to let you try these after you finish the Think, Pair, Share. Share your work with your partner. It shouldn't look exactly the same because you're putting it in your own words, but you can check with your partner to see if you missed anything. Then you're going to do these example problems. When everybody's ready to see the answers to these, we can play the next video. So I'm going to do these algebraically because that's the way I like to do it. 1/2 x plus 9 equals negative 5x minus 13. To get rid of the fractions and make my life easier, I'm going to multiply both sides by 2. So that's going to give me 2 times 1/2 is 1x. 2 times 9 is 18. 2 times negative 5 is negative 10. Still has the x. And 2 times negative 13 is negative 26. I'm going to add 10x. And I know some of y'all can combine these steps, but I'm going to show each one. That's 11x plus 18 equals negative 26. Subtract 18. 11x equals, that's going to be negative 44. Divide by 11. So x is negative 4. Now remember, just finding that one x value doesn't answer my whole problem. I need to plug it back into either one of these equations. I'm going to do the second one to find the y value. Now I should be able to plug it back into either one and get the same y value. It should work on either equation. So negative 5 times negative 4 is positive 20, and 20 minus 13 is 7. So we should get negative 4, 7. See if you did the next one right. 2/3 x minus 4 equals x minus 5. I'm going to multiply both sides by 3. I'm going to distribute the 3. 3 times 2/3 is 2x. 3 times negative 4 is negative 12. 3 times x is 3x. And that's a negative 15. Whichever way you want to subtract works. I'm going to have negative x minus 12 equals negative 15. I would have had less negative numbers if I'd gone the other way, but call it sick brain. I couldn't think today. That's negative 3. Sorry, my video keeps dying on me. Divide by negative 1, and you get x is 3. The second equation is the easiest one to plug into, so y equals x minus 5. 3 minus 5, I get negative 2. So my solution is 3, negative 2. And if you plugged into the other equation, you should still get the same thing. You can always check your answers on these. That's what makes them beautiful.